Hello students, welcome to lab exercise 5. We're going to look at some hypotheses testing using Excel's functions and processes. This will help you with the computer assignment for this section. So we're working on this. We're working on the same data file that we worked on for lab exercise 4. We did interval estimation. So the values in the data sheet will always change. We're working on this section here, hypotheses testing. So the first thing we want to do is go to the data sheet, hypotheses testing using the t-distribution approach. The t-distribution approach is used when we do not know the population standard deviation, so therefore we have to use the sample standard deviation, which we calculated up here. So if someone makes a claim that the population average is 100. We're going to use our data in the different samples to either confirm or reject that statement. Calculate the test statistic using 100 as a population mean and the sample mean standard deviation as previously calculated. This is the formula, so it's going to be the sample mean minus the population mean. We're going to manually type in 100. And we're going to divide by the standard error, which we've already calculated. We could divide by the standard deviation over the square root of the sample size, but that does equal the standard error. So there is our value. We want these values. Your value may turn out to be positive, but some values will be negative. We want these values to be given or returned as positive. So we're going to enter the ABS function in front of that. So you go ABS bracket, and at the very end, place another bracket. All the values will be positive. And we can drag that across. There's our values, and these values will change except for the last one. So the test statistic is that value there. The level of significance, we're going to manually type in 5%, and we're going to link that. So in cell C119, just go equals B119, and we can just copy that over. So we can change that to 10% or 0.1, and they will change over there, 0.01, so forth. So make sure that changes, makes it easier to help analyze some of our data. So step C, 1C is calculate the critical value of t by using the level of significance as indicated and the required degrees of freedom. Use the t-INV function. So we used that previously for the confidence interval. The probability is our level of significance, and our degrees of freedom is n-1. So go up here to row 106, click on that value, -1. And there is our two-tailed T-alpha value, or critical value. And if we copy that across, you'll notice that the values in row 111 and 120 will be the same. Basically, a two-tailed hypothesis test is the same as a confidence interval. So, step D, what's your decision for a two-tailed test at the 5% level of significance? Remember that our decision rule is to reject the null hypotheses if the test statistic, which we have in row 118, is greater than the critical value. So our decision here would be not reject, not reject, not reject, and the last one would be reject. But because these values are always going to be changing, we want to put in a function for that. It's a good old if statement. If the test statistic is greater than the critical value, we're going to go comma, in brackets, reject null hypotheses, quotation marks, comma, quotation marks. If it's false, we're going to type in do not reject the null hypotheses, quotation marks, and you close your brackets. We can see that if we press this button there it is. If B118 is greater than B120, reject or do not reject. And then we can copy that over. And of course, these decisions are going to change in the first 3 columns of data. Press and hold delete until it changes. Change once, and it should change approximately 5% of the time. P-value, we are on step E. Calculate the p-value for the test statistic for each column. This is a two-tailed p-value. We use the t-dist function. T-dist function. The x is the test statistic. Degrees of freedom, always n-1, comma, and then if it's one-tailed or two-tailed, we want to enter that it's a two-tailed test. So this is what I would have for the function here. X is B118, degrees of freedom, n-1, and it's a two-tailed test. Okay, and then we can drag this across. So our decision rule, if it's using the p-value approach, is to reject the null hypotheses if the p-value is less than alpha. Here the p-value is greater than alpha, so we would not reject it. Instead of typing in reject or do not reject, we're going to come up with this formula, if function. If the p-value is less than alpha, so if bracket, click on p-value, is less than alpha, basically reject the null hypotheses. And quotation mark, comma, quotation mark, do not reject the null hypotheses. And dragging that across. And the decision in row 121 should be always the same as the decision in 123, and you can see that it is. Press and hold delete over the side. There is our values. So based on some, 5% of the time, we should have our decisions should change. Now we're going to do the same process if it's a one-tailed test. So a couple things I want to go back and change slightly is in row 121 for the decision, we're going to make cell B118, I'm going to give that a mixed cell reference. So it should be $118, and then drag that across. For the p-value decision, the decision made based on the p-value approach, what we want to do is have a mixed cell reference for B119. So go into the formula for that, row 123. B122 is less than $119, and then drag this across. It's not going to change anything in our decisions, but it's going to make doing the second part a little easier. So row 125 is step G. We want to enter t-value based on a one-tailed test. There's a function for that. It is t.inv. This gives us a one-tailed value. Probability is still 5%. Level of significance, degrees of freedom is n-1. And there we have it. It will always give us a negative value because it's giving us T alpha, or critical value, based on the left end of the distribution. So we want to, at the very beginning of that whole function, is enter ABS, bracket, very end, put another bracket there to close it, and there we do. We have the same value. Copy that across. What we'll find is that this is a t-value, critical value based on a one-tailed test at 5% level of significance. Let's go to our t-distribution chart and just confirm that this is the right value. So we have 1.833 and 1.699 for 5, or sample size 10 or 30. Go here, it's 5%. It's a one-tail test, so we're not dividing by 2, so it's basically in that second column. There is 9 degrees of freedom, 1.833, and 29 degrees of freedom, 1.699. So then, we can change our level of significance. We can change our level of significance to 0.1, and it's going to, this t-value is going to match up with what it should be on our chart. We're going to make the same decision. We're going to make a decision using the if function based on a one-tail test. So, because we have went back and made this cell a mixed cell reference, we can copy the value from B121, place it into cell B126, paste it there, and then we can drag this across, and there is our decision. Our p-value, we're going to use one second here. P-value, we're going to use the same value here, t-dist function. X value is our test statistic. Degrees of freedom is n minus 1. And we go comma 1 because we want it to have, it's a one-tail test. And there's our p-value. Our decision is going to be based on our p-value, comparing our p-value to our level of significance, so comparing the value in row 127 to the value in row 119. So because we went back and changed added a mixed cell reference in the first p-value decision, we can go back and we can copy from cell B123 to B128, and we can drag this across, keeping in mind that our decisions in, there we go, we just had to wrap that text in 126. The decision we make in 126 should be the same decision we make in 128. We can go over to the side, we can press and hold delete. Our decisions will change, our p-values will change, basically showing how random the decisions are going to be based on our sample data, and that based on our level of significance and our threshold values, our decisions are going to be based on those values. So that is what we are doing for this lab exercise. We can also go back and change our level of significance. 0.1, decisions are going to then automatically be made on that. Of course, they'll change every time you press a button. Let's go back and change it to 5%, and there we have it.